Hello everyone, I'm Zhao Chen. I'm representative from Team 6 of the ME2024 class, Engineering Design and Economy. This is our team logo, T10. Let me introduce my other two teammates, Chelsea Edwards and Randy Limore. For the first several slides, I'm gonna introduce the review of the DP1. Just go by feedback about little elements from the DP1. In the DP1, we created a mission statement, we create the consumer profile and consumer needs and the specification and several other charts. And for the mission statement, we have like a product description about the tea timer is a device that steep your tea bag for a set of amount of time and notify you when the tea is finished. We also create a consumer profile by interviewing Virginia Tech students from different majors, and we ask them about their hobbies and some stuff and behaviors like that. And some of them give us some feedback about the use case when they use other companies' tea timers. The main feedback is about they face a dilemma when using different size of the teacup and which cannot fit in the standard like the machine, like the tea time machine. So we have to list that by creating our own consumer needs. So we created our own consumer need to achieve our goal to improve such dilemmas and some difficulties when students use. And we also create our QFD diagram to the specification of the manufacturing process about the tea timers. We consider about the weight, mass, volume, and other stuff. By combining the assumption, mission statement, product specification, and consumer needs, we create our functional decomposition, which means we have to make assumption that the consumers use the tea timers on the horizontally flat surface, and majority of our consumers are college students. And we also have our specification about the manufacturer specification about the weight, energy source, volume, and other stuff. And we also have to fit our consumer needs. We have 6 consumer needs, like notification of loud and cost effective. By decomposition, we have 2 main aspects. One is the energy, another one is the on-off signal. When the user, the consumer, use on-off signals, the Arduino board will receive the signal about that input. At the same time, the energy will transfer, like the electrical energy will transfer to the batteries or other components. And Arduino boards will then select the time, like for different tea, like the black tea is 5 minutes, green tea is 10 minutes, and combined with the energy, they transfer to the motor, like at the beginning, the internal countdown, which is the actual functional tea timer works. After a amount of time, like the motor will pull up the tea bag and to alert the user that the tea is finished, your tea is done, or coffee is done. And then you're gonna have a perfect tea. The consumer will have a perfect tea for the goal. In order to achieve a better goal, we have to consider 3 different solutions. The first one, we have to convert electrical energy to rotational energies. They have several selections, like button, switch, microphone, and for the rotor device, we have a DC motor, manual crank wheel, and other stuff. And the energy, we have a battery, solar panel, hand crank, outlet plug, and a USB power. And we have to select the best component that we have to use to build our high efficiency and the faster way. And here we go, you can see 2 different colors, it's black and red. That's like 2 different methods. Similar we use in the alerts, because the alerts, they have many selections, maybe have a vibration, maybe have the sound, maybe have the light signal. So we have a different idea. Also they have 2 methods to achieve the goal, like the alert. And also for the adjustability, we also have like a battery, some other stuff, energy stuff, connect the energy stuff to connect with each other. We also have 2 different methods. Finally, we have 6 different solutions. Like these 2 have a different out plug and battery. These 2 have different size. This is fit size. This is you can change the horizontal size. And we have to figure out which one of the solution is the best solution to build our T-timer for our project. So we have to use 3-2-1 method to share our ideas. So we have we have 3 persons in our team, and we have 2 rounds. Each round each of us gonna write our ideas on the paper, and when the time is done, we're gonna share with others by moving our paper to the another teammates, and then we can figure out which one is the best solution. And by using the 3-2-1 method, we also build up our mind mapping. We can figure out there's so many components for different ideas. Like adjustable, they have 3 different ideas how to adjust different sides of the cup. Like for the turn off, they have a different switch to how the user open the T-timers. We also receive many reviews from the team review, in the class. A majority of the people suggest us to consider about the material for the T-timer. Because you have to have the waterproof stuff, we don't have the material to resist the corrosion and the rust due to repeated use and contact with the same vapor. So we have to consider that the material used to build up T-timers. And we also have to consider about the leaf attachment for the water exposure and the washable, and the many stuff related to the material. And so we create our method like screening to determine which one is the best. We have 7 different ideas: battery, outlet, USB, blah blah, and to the lights. And we also have a different criteria, like easy of handling, easy of use. For now, we can figure out rank 1, we have a battery and a constant height, main idea for our design. For the scoring of the energy, briefly for the overall reference, we can see the batteries have the highest point. So we might use the battery for our final design and the components. We can see the easy of use is 20%, which means the consumer main focus on the easy of use and how easy to bring it to anywhere to use that. So the easy of use more weight, and the battery I think is the best component to feed that weight and get the highest point. And there we go. We have a final design like that. We asked the MIC department. The professor told me that a PLA material is better for waterproof and other resistant. And so we use 3D printing stuff for the horizontal supporter, and you can see this motor on the top, and we're gonna have our Arduino board on the side and the battery on the bottom, and to give the energy provide. And then you're gonna have wires go down to connect with a tea bag, and then you can figure out and then make a tea for the consumers. This is a key point, a 3D printing motor and the batteries. We hope we can develop such developments by have a better CAD and better code, and we're gonna figure out which kind of a PLA material to make a 3D printing, and then we're gonna figure out which one is more better and more efficiency for the student to use. And this is our final design, briefly like that. Yeah, that's it.